Namaskar. In the previous video, we had gone through the physical significance of the gradient of the scalar function. We had plotted the scalar function, then we have calculated the gradient, and there was a homework for you to find to plot this function h in yz plane and then find the gradient of this. Now we will go for the physical significance of the divergence, and this function was homework for you to plot this function, that is a is equal to yj cap plus zk cap. Okay. Now we will proceed with that function. I will write that function here. Let the function a bar is equal to yj cap plus zk cap. Now, as I told last time, we are considering the function only in yz plane for simplicity, because the x-axis is perpendicular to plane of the figure and it is not easy to understand the situation perpendicular to plane of the figure if I think about the diagram on the paper itself. Now again, I will extend the y-axis to the opposite side, at minus y-axis, this is minus z-axis, and for various values of x and y and z, that means keeping x to be equal to 0, the constant actually, and it is independent of x, therefore I can think about the functional values. But here you will realize that it is not just sufficient to give the values of function. See, because g was the scalar function y square, only the value, for example y is equal to 2, the value is 4. But here if I think about a point 0, 1, 1, then the function is 1 z cap plus 1 k cap, that means it is a vector. Okay. And how to plot the vector? For that I will think about a particular point. Let the point is 0. Okay, the origin 0, 0, 0. Here if I substitute y to be 0, z to be 0, then it is 0 j cap, 0 k cap, means it is null vector, the vector having 0 magnitude. For this point is y is equal to 1, x is 0, z is equal 0, therefore it is 1 j cap, that means it is 1 along j cap, the vector is something like this. This is the vector function at 0, 1, 0. If I think about a point 0, 0, 1, that is along z-axis, it is 0, 0, 1, it is 1 k cap, therefore the vector function will be along z-axis. Similarly, you can test for y to be equal to minus 1, x and z are 0, 0, the function will be along minus y-axis, that is minus j cap. At z is equal to minus 1 with x and y to be 0, the function will be minus k cap, that means along negative y-axis, negative z-axis. Here at y is equal to 1, z is equal to 1, you will observe that it is 1 j cap plus 1 k cap, that means 1 j cap plus 1 k cap, it is the resultant, and therefore this is the vector function at 0, 1, 1. At 0, 1, minus 1, the vector function will be something like this, it is 1 y cap, that is 1 j cap minus 1 k cap. At this particular point, that is 0, minus 1, 1, the function will be along this direction. At this particular point, that means it is 0, minus 1, minus 1, the function will be along this direction. If you observe the point, suppose it is 0, 2, 1, that means this point is 0, 2, 1. Ignore the x-axis, always x is equal to 0. We are talking for yz plane only. And second thing is that if I change the value of x, that is perpendicular to plane of the figure, these lines remains as it is, just we will have to lift them in upward direction or lower them in downward direction along negative x-axis. Therefore, they are moving away from the x-axis. If x-axis is perpendicular to plane of the figure, the lines are moving away from the x-axis. But here you will observe that it is 2 j cap plus 1 k cap. Therefore, it is 2 j cap along this and 1 k cap. The vector will be something like this here. And same for so many points, you can plot the vector here. The vector will be like this. If the point is 0, 1, 2, that means z is equal to 2, then you will realize it is 1 j cap plus 2 k cap, 1 j cap plus 2 k cap, and therefore the vector will be like this, here the vector will be like this, and so on. Everywhere you can plot the vector function. Okay. Now you will observe that this vector function is such that it is moving away from the x-axis. Everywhere it is moving away from the x-axis for any value of x. Now for different values of x, it is not possible to plot the function on paper, but you can imagine. Suppose x is equal to 2, then all these lines are to be left in upward direction by 2 unit. If x is equal to 5, all those lines are to be left by 5 unit. For x is equal to minus 3, we will have to lower them by 3 unit along minus x-axis, but they are moving away, lines are moving away from the x-axis, always they are moving away from the x-axis. Okay, this is the nature of that function. One more situation is that suppose this is a function on xy plane, and suppose these are the lines, and if I release some light object on this, what it indicates that the object which is left somewhere here will move away from this direction. If the object is left somewhere here, it will move away this. That means they are moving away from the origin, everywhere away from the origin, correct? And it is symmetric about the origin, everywhere it is symmetric about the origin. Means the functional lines are diverging away from the origin, correct? They are diverging away from the origin. This is a situation. And now we will check. If I plot the divergence of a bar, that is del dot a bar, now you are aware about solution of this, and therefore directly I will write it is 1 plus 1 derivative of x with respect to, that means derivative of coefficient of I cap with respect to x is 0, derivative of coefficient of j cap with respect to y is 1, and derivative of coefficient of k cap with respect to z, it is 1, and that is equal to 2. Therefore you will realize that this is just a number. Okay, divergence is a scalar quantity, and this 2 now here it is difficult to explain you what is the significance of 2, why it is 2. Now it is possible, but it is bit complicated, because actually when we think about a derivative d by dx, I will have to consider a small change in x, correct? And here I have considered the change by 1 unit along y-axis, 1 unit along z-axis. In case of the gradient, we have assumed the mean value of change. For example, if I change the value of y from 1 to 2, then we have considered y average value of y to be 1.5, and that was matching there. But for y cube, y raised to 4, it may not match, because the derivative is significance is there only if delta x is 0, very small, limiting case, correct? And therefore right now keep this aside, but it indicates that it is moving away from that. And now you will think about one more function. Say for example, if I think about another function, let d bar is equal to, I will write it is minus yj cap and minus zk cap. Then negative sign indicates that we will have to invert the directions of vectors, and immediately that y, this 2 becomes minus 2, correct? Therefore here it is divergence of d is equal to minus 2, and you will realize that the field lines are converging towards a particular point with a convergence of 2, and here the divergence is 2, that means they are diverging. Now if you are interested, then you can think about such a situation and try to correlate why it is 2, and for that you may think about a different function. Say for example, y square j cap plus zk cap, you may plot that, and then you can realize that if it is y square j cap plus zk cap, then it will be it is 2y plus 1, and it depends on the value of y, and then therefore you will realize that. Now it has to do something with the flux entering a particular volume and flux leaving the particular volume. For example, if I think about a certain volume somewhere here, then you will realize that few lines are entering this and few lines are leaving this, correct? Few lines are leaving this, therefore it has to do with flux. And therefore if the total flux entering this volume is, suppose it is phi 1, and the resultant flux leaving this is phi 2, then phi 2 minus phi 1 is known as the divergence. The overall flux is moving away from this, and later in some higher level you may realize what is the meaning of the divergence, exact meaning of the divergence, but for right now it is sufficient. That means it will give you the divergence of that vector function. Now obviously for some complicated functions, if I think about p bar is equal to 2xy square I cap minus 3xy z cube j cap plus suppose 4x k cap, you may calculate the divergence, but it is not possible, or it is a bit complicated to represent this in vector form and to interpret the divergence, because the divergence depends on the position, and it will be definitely complicated, not difficult, but it is complicated, it will be complicated. But to understand the meaning of divergence, we have considered a very simple function, that is yj cap and zk cap, and here we have observed that the function is moving away from some point, that means it is diverging, and therefore it is plus you may think about the value magnitude later on. But if it is converging, that means if I flip the direction of all the arrows by considering the function d to be minus yj cap minus zk cap, then the divergence is 2 and it is with negative sign, therefore it is convergence. You will realize that the function is converging. In the next video, we will discuss what is the significance of curl up to certain extent. Thank you.